In this video, we're going to start looking at the strategy for doing complex derivations in SD. So we'll start by working on this derivation here. So if you remember what this says, right? Here we have a set containing one sentence, and this single turnstile here, that's the derivability sign. So this claims that this sentence is derivable from the set containing this one sentence. So we'll construct a derivation to show this. Now, when you're working derivations in general, remember that in the textbook on pages 167 to 68, there's a summary of the derivation rules. So, I mean, the rules of SD. So, it's a good idea to keep your textbook open to those rules so you can double check, make sure that you're using them all correctly. Um, just to make sure that you don't make any mistakes. Um, so we're going to start by we'll set up our table. Going to need 3 columns, and we're just going to make it nice and big. We don't know how big of a table we're going to need for this, so we're just going to take a nice big table. Now we'll start by copying in our assumption here at the top. We label that assumption. That's our line 1. We will have a scope line here, but we're going to put that in at the end. Now, the main connective of this is a conjunction. So we can apply conjunction elimination to it, and we can derive both of the conjuncts from it. So we can do that step next. So we can get this and this by conjunction elimination. Okay. So we can do that. Now, what we're doing at this point here is called working top down, right? So we're starting with what we have at the top of the derivation. We're looking at what we can infer from that, and then we're drawing those inferences. You actually do very little of that when you're working with SD, and you can kind of see why you do very little of that, because we started with that assumption. We pulled out both of the conjuncts. We can actually delete those parentheses around these. We don't need them. And here's the thing. Now we're stuck, right? Like there's nothing further that we can do at this point. These 3 lines that we have up here, there's nothing more that we can do with these, right? Like there are no further inferences that we can draw from them. If you keep trying to work top down here, what's going to happen is you're going to start making random inferences just in the hope that it will get you somewhere. And if you're just making random inferences, then well, it's not going to get you anywhere, right? If you're just picking things at random, that's not really going to help you. So when you're working top down and you can't go anywhere, what you need to do is you need to go down to the bottom of the derivation and you start working bottom up. So when you work bottom up, what you do is you write in your goal sentence, and that is the sentence that you're trying to prove. So that's this, and this goes at the bottom of the derivation. When you put this in, you leave out the line number because you don't actually know what line this is going to be, because you don't know how many intervening lines there are going to be between here and here, right? That's why we put this in at the bottom. We don't actually know how much space there's going to be between these two. Next, you look at that sentence and you think, okay, so how can we derive this, right? What is it that, what rule can we do? What rule can we use to derive this? And then what would we need earlier in the derivation that we could derive this from? So you can go through the rules. If you look at pages 167 to 68 of the textbook, right, you can go through the rules and you can see there are various possible ways that you could use to derive a conditional. But the main one The one that's going to be most useful, the one that you would use pretty much all the time if you want to derive a conditional, is going to be conditional introduction. So we will set things up to use that. The reason why this is the one that you're going to use almost all the time is this is the safest bet. If a lot of the time conditional introduction is the only way that you can get a conditional, and if it's not the only way that you can get a conditional, then the worst that happens if you try using it is your derivation will end up being a couple lines longer than it had to be. So we will assume then that we're going to get this by conditional introduction. So we write in the rule that we're going to use to get it by over here in the justifications column. You don't write in any line numbers yet because we don't know what line numbers we're going to get it from. I mean, those lines don't exist at this point. Then we're going to start writing in what we would need. So for conditional introduction to work, right, what you need is you need a subderivation that goes from the antecedent of the conditional to the consequent. So we'll draw in the basics of that subderivation. So we need to introduce a new column here that is going to be our subderivation. It needs to start with the antecedent. So we know that it's going to start with this assumption, and it's going to end with the consequent of the conditional, so C. We know this is going to be line 4. We can put in the line number here. We can't put in a line number for this yet because we don't know how big this subderivation is going to be. So we've got this now. Now, what happens is this is now our new goal sentence. So how do we get C? That's the new question that we have. For that, what we can do is we can look at the earlier parts of the derivation. So if you look up here at line 2, we've got if A then C. So we have if A then C. If we have, given that we have this, if we also had A, we'd be able to get C by conditional elimination. So let's write in, we'll write in here conditional elimination. Let's copy this horseshoe here. We'll put in conditional elimination as the rule that we're going to use to get C. And then the line that we're going to need to get it is going to be A. Because we know that since we've got this, if we have A, then we'll be able to get that by conditional elimination. So now the question is, how do we get A? And here, the answer to that should actually be pretty clear, right? We can get A by conjunction elimination from line 4. So this we can actually just write in, right? We have we put in that we get the A by right, conjunction elimination from line 4. And now, so what we've done, like the goal when you're working bottom up is you get your goal sentences, you figure out how you could get those goal sentences. That allows you to put in more goal sentences above them. And what you're trying to do is, as you're working bottom up, you're trying to get to the point where you can join up the top and bottom of your derivation. And that's what we've accomplished at this point, right? We've established more and more goal sentences until we got to one where we could just see how we can infer that from previous from lines that we already had in the derivation. So now all we need to do is we just need to go through and fill in all the line numbers because our derivation is done. So this is going to be line 6, and we have inferred this from line 5 and line 2. And you could write that as either 2 comma 5 or 5 comma 2. It doesn't matter what order those come in. This is going to be line 7, and this is being derived from this subderivation here, which runs from line 4 to line 6. So 4 to 6, conditional introduction. And then the last step that we're going to have is we're going to draw in the scope lines. that go here. And remember that you need to do that because now that we're working on complicated derivations, you're going to need these to make it clear where these subderivations are, because these tables are not, they just don't make it clear enough where, if you have a lot of subderivations in them, they don't make it clear enough where where exactly these subderivations are. And you could also go through and move things around a little bit, delete some of these intervening lines. We're not going to worry about that stuff right now. The last thing actually that we will do is we will go through, because we didn't use these lines. So we're just going to delete them. And there we go. Now our derivation is complete.